begin with the Newland law of octaves. So before we begin, let me remind you something. I hope you remember that in the previous video, we discussed that studies were being carried out from time to time in order to find out such a convenient way of a representation of elements so as to make the study of the elements easier and in order to establish relationship of one element with an other element. And there were so many scientists who came time to time and gave their contribution in this context. And one was Dobereiner, who gave Dobereiner's triad, okay, about whom we discussed in the last video. If you have not watched the video still, you may watch it on my channel. Okay, so now after Dobereiner, there came another scientist, and he was Newland. Yup, he was Newland, who gave his theory in the year 1865. So before I tell you about Newland and his theory, let me remind you something that we studied in the last class, which will have a direct connection with today's lecture. Okay, so I hope you remember that it took a name of one scientist, and that was William Prout. So William Prout was a scientist who discovered that atomic mass of an element never differs, and it could therefore form a truly scientific basis for the satisfactory scheme of classification. William Prout was a person who, tried to figure out that what can become the basis for the classification of elements. So he discovered, his assumption was that atomic mass is something that never differs from one element to another, because at that time isotopes were not known. So he had this assumption that atomic mass is something that differs, from that varies from one element to the other. And hence, upon his assumption, upon his theory, other scientists came and brought his theory into practicality. And the first scientist to bring the theory of William Prout into practicality was Dobereiner, who gave the theory of Dobereiner's triad. Now there came another other scientist who gave his theory who further brought up his theory or enhanced the Dobereiner's triad, maybe we can say, or he gave his theory in context with William Prout's assumption, and that was Newland. So John Newland, he was a scientist and a lover of music. So now this John Newland, he gave his theory in the year 1865. So John Newland, he arranged the elements in ascending order of their atomic masses. In ascending order of their atomic masses, this is a very, very important point, because right now we are talking in context about the atomic mass, which was the assumption made by William Prout. Now these scientists were bringing that assumption into practicality. So this is what Newland also did. He tried to arrange the elements in the ascending order of their atomic masses, and he found that every eighth element had properties similar to the properties of the first element, just as the eighth note of a musical octave is the same as its first note. In your music classes or in music, you might have heard about sa re ga ma pa, right? So these are the notes of music. So as he being a lover of music, he tried to correlate the music notes with the periodic classification of elements, and he found it to be applicable sufficiently. Okay, so like for example, there's a table that you can see on the screen. So it's like it's right now it's written in the Western music, do re mi fa and all, but in Indian music to Indian music tone is something like sa re ga ma pa dha ni sa, kind of like this, right? So what is observed here is that the first note, the eighth note of the music is same as the first note, like it is sa re ga ma pa dha ni sa, then sa repeats again, right? Similarly happens in the case of elements. Okay, similar thing happens in the case of elements, like in this case helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, then fluorine, then sodium. So hydrogen and fluorine, they'll have same properties. This was establishment because they are lying in the same musical note, right? And the important point to be noted here is that noble gases like neon, krypton, argon, all these gases were not known at that time. They were not known at that time. That is why they are not even mentioned in the table established by him. Okay, so you need to remember this point. This is very important. So this was his establishment that he tried to correlate the properties of every eighth element with the properties of the first element from where we started counting. Like for example, if you look at the table properly, so if we count from hydrogen, 1, 2, 3, 4, 5, 6, 7, then 8. So hydrogen and fluorine will have same properties, right? Hydrogen, fluorine will have same properties. Now if I start counting from lithium, so 1, 2, 3, 4, 5, 6, 7, 8. Now lithium and sodium will have same properties. So this was his establishment, and this was the thing that he thought for. Okay, so now I'm repeating the theory again. So, according to Newland's law of octaves, when elements are arranged by increasing atomic mass, the properties of every eighth element starting from any element are a repetition of the properties of the starting element. No matter from where you start in this table, the properties of the eighth element from the starting element, that will be same with the eighth element. Okay, so this was his theory. Now, Newland divided the elements into horizontal rows of 7 elements, each which is shown in the table that you can see on the screen. And the important point, as I already told you, that noble gases were not known at that time. That is why you can see that noble gases are not mentioned here. Like hydrogen, helium is not there, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon is not there, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon is not there, potassium, calcium. Okay, so this is what he thought for. Now, talking about the characteristics of the law of octaves, which are given by the John Newland. So, this system worked quite well for the lighter elements, like for example, lithium, sodium, potassium. They were brought together because their properties matched. They complemented with each other, right? So, this was establishment that this system worked quite well with the lighter elements. This was a merit of the classification that he laid. Okay. Now, the second point or the second merit of his classification was that he was able to relate the properties of the element to their atomic masses. That means he brought the theory of William Prout into practicality, and it worked quite well. Okay. Now, for the first time, it was shown that there is a distinct periodicity in the properties of element. Okay. So, first time it was established that there can, something found out something that was very innovative. He thought for something that was so unique in nature, like how he could relate the properties of the musical note, the musical note with the properties of the elements. So he tried to correlate the periodicity in the properties of the elements with the musical tone. This was something very innovative, very creative, very unique. So this was his, merit of his classification. And for this, Newland was honored in the year 1887 as well. Newland was honored in the year 1887. The Royal Society presented the Davy Medal to Newland in the year 1887 for his work on the classification of elements. Okay, so moving forward towards the limitations of Newland's law of octaves. The modern periodic table that we have today is the proof that the law of octaves was discarded in the past, because the modern periodic table that we have today is nowhere related to the law of octaves. Even though Newland's contribution in this context was really significant, he was the first scientist to establish such a periodicity, to discover such a periodicity and relationship between the elements, and he gave such an innovative and unique idea about the classification of elements. But his theory was not applicable and convenient enough, hence it was discarded in the past. Let's see what were the reasons for the discarding of the law of octaves. So, this classification did not work with the heavier elements, that is, those lying beyond calcium. As more and more elements were discovered, they could not be fitted into the Newland's octaves. The first point. Okay. So most probably, as we know that at the time of Newland, there were 56 elements that were known, right? But the law that was given by Newland, that was only and only applicable up to calcium, that is the 20th element, right? It was only applicable up to calcium, and this law could not complement well with the heavier elements that lie beyond calcium, right? For example, iron, ferrum, right? Copper. All these elements lie beyond calcium, but this law was not applicable enough for them. So it remained only confined up to calcium, hence it was not so convenient and the further coming elements could not be fitted into this law of octaves. Hence, it became one of the most significant reason for the discarding of the law of octaves. Secondly, and the most significantly, Newland tried to adjust two elements, they were cobalt and nickel, in the same slot, and these were placed in the same column as fluorine, chlorine, and bromine, which have very different properties than these elements. Okay, so cobalt and nickel, you might have seen in the table that I had shown you previously. In that, cobalt and nickel were placed in the first slot and in the same column below, in which the fluorine, bromine, and chlorine were placed. And their properties did not comply with each other, complement with each other, right? So that was a wrong or very insignificant sort of placement, classification. Okay. Secondly, iron whose properties complemented well with cobalt and nickel, that was placed far away from cobalt and nickel in the classification. So this was a great and very significant, very insignificant kind of demerit in the periodic classification of elements given by Newland, or the law of octaves given by him. Hence, his law was discarded in the past.